Good morning everyone and welcome back to my channel. Today we will see how to obtain this kind of surface. Look, this is a complete surface, so if we bake the results, it is only one surface, and normally in Rhino it will be not easy to realize this kind of surface. Here in Grasshopper it takes a bit, but it's an interesting for me an interesting definition. So don't lose our time and start with the explanation of the definition. So we go into shaded view and let's see how it works. Basically, we first create this part and then we are going to modify it with some other issues. Now we create a rectangular curve, we fill it with a boundary surface, we create a grid with divide surface, grid of point. I use 93 as UMV division number. Then I offset the surface, create a second surface, and the value is 100 in my case. And then I'm going to create a diamond grid, a diamond panels into the offset surface, and I select wires in order to select only the boundaries, and then I join them in order to have closed curve, polyline curve. And then I pull the point of the first grid, of the basic grid, through in the direction of the joint curves of the curves we just created. And now I analyze the vector that start from the starting point to the pulled point, and I use to do this I use vector 2 points. Then I take only the versor, so the vector with amplitude of 1. Then I take the distance that comes as output to pull point, and I take 100 and divide it for this value. So I have a number less than 1, and then I multiply these values for 100. That will be my amplifier 2. Okay, now I have a versor and an amplitude. I'm going to create a vector with this direction and this amplitude. Then I'm going to move all the points coming from the first list, move all the points of this vector. And this is the first very important part of this tutorial. So now what we have is this, we have this definition of point. And if we apply surface from point, we obtain good results that you can also see in this tutorial. Now we are going to create more interesting part. Now we want to organize this definition, this composition of point here in by the direction, by the so we want to, if we look to the final results, we want that this surface variate in relation to the x. So less x, more diamond grid is pronounced, is highlight, and if the x is bigger, we go in the direction of a flat surface. until we reach the flat surface on the right. So we take the starting point, we deconstruct them, and we take the x values here, and I remap the values. So I create first, as usual, boundary domain, and then I remap it. I remap the x values into a domain that is from 0 to 1. Now I create a graph mapper here, and this part of definition is created in order to replace the value bigger than 1 with the number 1, properly with the number 1. So if the result is bigger than 1, because in this area the result will be bigger than 1, I don't want it, so I want that the values follows this graph, and when it reach this position here, so when the values of the epsilon is 1, then remain 1. So the want the value to the graph mapper to be like this. Perfect. So now I say if the value is larger than 1, then and so the result is true. Result you have to replace all the values for all the index for which the result is true with simple the number 1 that I stored in this panel. This kind of data after this is amplified by this multiplier here. The value I use is 100, and then I'm going to do another evaluation. And so I take the moved point, I value of this moved point the z, so the height of the point, and then I set threshold values, and I say if this value is less than these threshold values, then you have to do something. If it's bigger, you have to do other things. So basically I dispatch the list we created before with this part of definition, this part here. So I divide this list in relation to this sequence of true and false. And I say so take the values less than this, smaller than 73, in my case 8,000 values, and divide the list in order to obtain the correspondent values coming from multiplication. Then what we want to do is replace from the z list, replace the value with the replace each one of the values that have true as answer to this question here with the value coming from the graph mapper. And after, replace the data that have false as a result of this operation with the fixed value of 100 that is here. So basically what we obtain, we obtain, so if we come back this with the result values, if the z is bigger than 73, then you have to use 100 as a result. If the values is less than 73, then you have to use the value that come from this graph mapper that we used before, and so it will be from 0 to 1 value amplified by this multiplier here. So at the end we apply these two replays in sequence, and at the end what we obtain is basically a z values that we go to insert into this construct point component, and then we have our points that we can easily with this flexibility component use to create a surface that is a very complicated surface on the left and a flat surface on the right. Hope you liked the video, and see you in the next tutorial. Thank you for watching and have a nice day.